Thanks everyone for coming. Today we have an important day, and I'm not speaking about the game, but about Flutter accessibility. So first of all, I want to start by showing you a reality check. I'm going to show you a screen recording of what a standard pretty app looks like to a user who relies on a screen reader. And it's not just about compliant, it's about keeping your customers. Let's try this.
Sign in, heading, secure app, email. Enter your email, text field. Double tap to edit. Password. Enter your password, text field. Double tap to edit. Remember me for 30 days. Sign in. Apple.
Yeah, Apple. So as you can see, this is not really smooth experience, partly smooth. The critical problem is social login buttons at the bottom. Google, Facebook, Apple are purely visible, but they are not announced to the screen reader. So if the user wants to log in with social login, they just cannot, and you lose your customers straight away. So let's look at the actual rules. The European Accessibility Act is now fully active. It changes things completely because it moves past government software to target private consumer apps. If your app handles bank accounts, sells products, or books travel tickets in the European market, you must follow these rules by law. It's no longer optional. There is specific detail here regarding local markets. If your app is exclusive to the UK store and not distributed in Europe, you are technically not bound by the EAA. However, do not assume you are completely safe. UK courts and consumer groups still look directly at WCAG 2.1 level AA standards during legal disputes or discrimination complaints under domestic laws. So if your app fails basic accessibility, you can still face major legal problems locally. Following the standard baseline is simply the smart way to build your software. So ignoring these rules carries real consequences. Regulatory bodies can fine your company, or worse, force Apple or Google to push your application from the store until it's completely fixed. Trying to rebuild a broken user interface under an emergency legal deadline is stressful, messy, and expensive. It's much easier to do it right the first time. So to build clean apps, we need to understand how Flutter handles this under the hood. So we all know the standard 3 trees used to draw pixels. But Flutter also maintains a hidden fourth tree, the semantics tree. This structure translates your Dart layout directly into native platform elements. Because of this bridge, native tools like iOS VoiceOver and Android Talkback handle your application exactly like a native Swift or Kotlin app. So let's have a look at examples. So we start with, on the left, we see properties of semantics widget. And there are about maybe 50 of them. Let's have a look on the most important or frequently used ones. So label provides a descriptive text, while hint clarifies the action's outcome. For interactive controls like checkboxes and switches, we use checked, toggled, and mixed to signal specific states. They are mutually exclusive, so using the correct one prevents conflicting platform announcements. On the right, we manage properties that track both the widget's role and its functional relationship. Button explicitly triggers native OS role hints, and enabled is our core interactive flag. Expanded is basically whether your widget is expanded or collapsed. And quite interesting one is controls nodes, is about linking and like a tab or expansion tile, you basically tells how these widgets links together. Sometimes platform default algorithm that usually basically reads from left to right or top to bottom doesn't align with logical flow of your UI. And that's why sort key can be handy, and it allows you manually force a specific reading order, ensuring screen readers users navigate your app in the sequence you intended. So sometimes it can be quite helpful. Sometimes Flutter default tree structure results in fragmented experiences. For example, if you have a checkbox next to a text, the screen reader might read them as two separate, unrelated items. This can ruin the user workflow because they can't confirm the label describes the checkbox state. At this stage, we use merge semantics to force this into one cohesive unit. It collapses the subtree into a single node, ensuring the label and the state are announced together. However, use it with caution. Merge semantics is a blunt tool. If you merge subtrees with conflicting properties or multiple gestured handles, the operation system might announce confusing information or route interactions incorrectly. Sometimes less is more. Not everything in your UI needs to be read aloud. For example, exclude semantics is a surgical tool that silently drops all semantic data for an entire subtree, perfect for decorative clusters. We also have a convenient exclude semantics property on the semantics widget itself, which is massive time saver for parent-level silencing. Also, we have additional widget, and it's called block semantics. This is critical for model experiences. While high-level functions like show dialog handle this automatically under the hood, block semantics is a tool you need when building custom overlays inside a stack. It commands the operation system to drop the semantics of every widget painted behind. It is the same container. So this ensures smooth user experience and removes extra semantic noise and provides best overall user experience. This is where teams run into trouble. Standard buttons have accessibility built right in, but the moment you build a gorgeous, completely custom button using a raw gesture detector and a container, it becomes completely invisible to a screen reader. It looks perfect to you, but to the operation system it doesn't exist. You have to explicitly tell the framework what custom widget actually does. Before you start wrapping every single line of code in brand new semantics widgets, check what Flutter already gives you. Some widgets have shortcuts built right into them. For example, a standard text widget automatically assigns its string value as a semantic label without any extra work. Many asset and image widgets have built-in parameters to exclude them from screen readers. Always look for these native shortcuts. Mobile apps are not just for touchscreens anymore. Users connect Bluetooth keyboards, trackpads, and assistive switches to their phones. Because of this, your interactive items must support 3 core states. Hover is for pointer devices. Focus is what tells a keyboard user exactly where they are on the screen, and pressed gives immediate visual confirmation that an action happened. Beyond these big 3, Flutter's widget state API also tracks more specialized conditions like disabled, selected, dragged, and error, allowing you to build highly responsive UI that reacts to every possible way a user might interact with your code. Testing these states on a standard phone simulator can feel clumsy. A tip is to run your Flutter application targeting the web or desktop during development. This lets you test everything instantly. You can hover with your mouse to check hover styles, hit the tab key to watch the focus ring jump smoothly from field to field, and press enter to confirm the item triggers its press state correctly. Let's look at how this looks in the code. A standard elevated button handles all basic interactions automatically. But for a professional app, you often need to customize how the states look. The core tool here is widget state property resolve with. This allows us to define logic that checks the current interaction, set like pressed or hovered, and returns a specific value. In this example, we manually lower the elevation when pressed to simulate physical contact and drastically increase it in hover to provide a clear depth cue for mouse users. We also map our brand colors to these states. So muted gray for disabled, a deep indigo for pressed, and lighter shade for hover. Most importantly, for accessibility, we use focus state to swap out the standard border for a high visibility double ring, ensuring keyboard and switch control users never lose track of their position on the screen. Yes, it's here. Sometimes you need absolute design freedom, but custom widgets shouldn't sacrifice accessibility. This code demonstrates how to build 100% custom button using an inkwell and a widget state controller. The controller acts as our state listener. Whenever we use hover or focus states, it updates automatically. We wrap our layout in a listenable builder, which detects the controller changes and triggers a surgical UI rebuild. Inside the builder, we simply query the controller's value set. If it contains focus, we draw a high contrast white border. If it contains hovered, we swap the background for a darker brand shade. It's important to remember that our previous custom button can be written in many different ways. The manual approach using multiple booleans and deep widget nesting is a common alternative, but it's often not the best solution. It makes the code harder to read and easier to break. As engineers, our goal is to find the most efficient and readable solution for each specific case, usually favoriting modern API like widget state controller. Finally, let's look at an advanced pattern for form inputs. Professional accessibility often means not showing a focus ring when a user simply taps, but showing it clearly when they use a keyboard tab. We achieve this by listening to the focus node and checking the highlight mode. If it's traditional, we know the user is using hardware or assistive tools. We provide a clear, high-contrast feedback only to the users who actually need it. Yeah, it's here. Let's clear up a misconception found in documentation. Many developers think they can use standard Flutter key properties to locate items during automated testing. That doesn't work. Standard keys are used internally by Flutter and are stripped out of release builds, leaving black box testing tools completely blind. To fix this, the Maestro team worked directly with the Flutter engineers to add proper, stable native semantic identifiers to the platform. This update allows us to completely separate our testing structure from human text. We use semantics identifiers as a permanent technical ID for automation scripts. It's completely hidden from screen readers. We then use semantic labels for actual human-readable text. This means if your translation team updates a button from English to Spanish, your automated tests won't break, because the technical identifier remains exactly the same. Maestro is incredibly powerful for accessibility testing because it treats you like a black box. It looks at the final compiled native accessibility tree just like an actual user or a screen reader does. If a developer builds a custom element incorrectly and forgets the semantic properties, the automated tool won't be able to interact with it. A passing test is a real proof your layout is working correctly. So you don't need to write complicated test code to see if your layout is tabbed correctly. By running Maestro Studio in your terminal, you get an interactive visual inspector in your browser right next to your running device. You can click on any widget on the screen to instantly view its native identifier and screen reader label, as you can see. As great as automated testing is, it has limits. A script can tell you that an accessibility label exists, but it cannot tell you if that label sounds confusing or if the reading order feels completely out of place. To ensure a high-quality product, someone on the team must physically pick up a device, turn on screen reader, and walk through the core flows manually. Unfortunately. Yeah, it's too small.
How would the screen reader work here?
Yeah. Not accessible. Many engineers avoid manual testing because they are afraid of getting stuck in screen reader mode. When standard touch gestures change, it's easy to panic while trying to navigate complex system setting menus to turn it off. Save time by using hardware shortcuts. On iOS, you can set up a triple click on the power button to toggle voiceover, or just use Siri. On Android, holding both volume keys down for 3 seconds shut it off instantly. Use these shortcuts to test your app quickly and efficiently. So here's a vital lesson for working with cross-functional teams. Designers sometimes confuse the keyboard focus state with the screen reader highlight frame. They're completely different. As we saw earlier, we can customize keyboard focus states however we want, adding double border or custom colors. But screen reader highlight frames are drawn entirely by the native operating system to keep things consistent for low vision users. You cannot change their color or shape in code. make sure your design team understands this boundary before production starts. It was a problem in our team. Oops, So yeah, now let's look at the same UI with semantic rules we have discussed applied.
Sign in, heading. Logo, secure app. Email, enter your email, text field. Double tap to edit. Password, enter your password, text field. Double tap to edit. Remember me for 30 days, switch button, on. Double tap to toggle setting. Off. Sign in, button. Sign in with Google, button. Sign in with Facebook, button. Sign in with Apple, button. Success.
Success. So notice the difference. So it's a little bit more smooth experience, and now we fixed our social buttons and basically turned at that end into a functional, inclusive user journey. So this is the difference between a broken app and a professional, inclusive product. So let's summarize what we covered today. At first glance, comprehensive accessibility can seem overwhelming or complicated, but Flutter gives us a very clear, straightforward path to support it. The trick is balance. If you panic and start blindly wrapping every single widget in your code with semantic tags just to make your automation tools happy, you will create semantics pollution. This ruins the experience for screen readers users and makes your code a messy nightmare to maintain. Focus on clean layout architecture, use your testing tools smartly, and keep things simple. Let's make our apps more modern and provide a better user experience for everyone with proper accessibility support. Thank you.
Thank you, Dennis. Anybody got any questions? Tom?
Thank you, Dennis. I was pleased you mentioned about being able to test on the web and get kind of good enough testing.
Yeah.
That sounds like that will speed things up for engineers and take away some of those barriers. Have you found that there's anything in particular that doesn't work with accessibility testing for the web compared to when you're then running on iOS or Android? Are there time day to day, right? We find UI issues that might be present on the web or not compared to iOS or Android. So we still have to test on devices. Is there anything similar with accessibility testing?
Yeah, so specifically for like hover states, quite useful because you cannot really easily test on physical device hover state or keyboard state unless you connect a keyboard. So it's very useful, but if we speak about screen readers, you basically must to test on physical device to have this proper test. Otherwise, you would not be able to really understand. So unfortunately, you have to do both.
Sure.
Yeah.
Yes.
Is it mandatory to provide accessibility on all pages of the application? For example, what about long scroll lists, etc.? How does it work? Is it necessary?
Yeah, I believe according to the EAA, you have to provide accessibility on all of your screen pages, specifically major ones. If user cannot interact with some parts of your app, it can be a complaint.
Challenging for hybrid apps and, for example, for experiences that have PDF reader or something like that, PDF viewer. If you display documents, that's a problem.
Yeah, it definitely can be a problem. So it's a lot to consider, and it's not easy. and sometimes it's really you have to struggle to provide accessibility to every part of your app.
And the gentleman at the back.
So where do I find out more about semantics in the create init work that you've done with him?
Where do you find details about
Where do I
semantics?
find more about semantics in the create init work that you've done with him?
Where do they find out more about them? I mean, have you got any resources to share?
Feel free to contact me.
I think somebody else had a question over here.
Yeah.
George?
Yeah, so, thank you so much, first of all. So, rooting of what you asked, when you have like a design system for application like the team settings,
Yeah.
the dark mode and all, do you also have like a setting for the semantics? Because most of the IDs are hard-coded. In a situation where probably you want to have the signing with Google or Apple in another screen, do you like copy the text or do you have like a setup you have for it so that if you have multiple engineers working on the same product, they maintain the same, let me say, enum that they're using for the ID. So you don't have maybe Camel case signing with Google, Pascal case signing with Google, which varies a bit.
Yeah, so regarding design system, you can a lot of handle inside design system, like all these hover states and other stuff, but about passing the keys and you have to identify and agree with your QA your approach, what they would like to see. For us, it's lower undercase, and there are different approaches, and you can create some helper classes and to manage it, and try not to write it by yourself every time. So different scenarios, but it's the best is try to not do it differently on every screen and try to stay consistent. Yes, thanks.
Thank you.
Anybody else?
Yeah.
Yes, Sean.
How do you handle, as you refer to it, semantics pollution? So let's say, for example, like the semantics duplicate, you've used the default Flutter widget, but then you've also wrapped it with your own semantics. Do you really care that there's a duplicate if your screen reader works okay? Or do you have, say, a good process of figuring out that kind of duplication?
Yeah, so first of all, what I do is quite easy to inspect all your semantics with Maestro, because you just launch and you see basically Maestro draws every semantic node that you have, and you can easily spot that you have some extra semantic containers that should not be here. And then, of course, it's good to have a physical check on your real device, and you can spot when you navigate that some extra stuff is coming, and definitely you should fix, and then you can go inside deep and debug and remove some extra unnecessary stuff. It will happen.
Okay. So always for the screen reading purposes, we want to go through manually on a device?
Yeah. What we do once we finish screen or feature, we do a physical test of screen readers, and then you can easily spot the problem and try to fix it as soon as possible.
Thanks.
Okay, the gentleman at the back again.
I've had some issues with Patrol and semantic labeling when testing. Is it an easy transition from Patrol to Maestro?
I don't know. I haven't checked Petrol, so I cannot say anything on this.
Okay. Paul.
Does Flutter have built-in support for users who would use a gamepad controller? So if you're making a game in Flutter or something like that. So, I mean, obviously things like menu screens and so on might be quite tricky.
Yeah, I guess so. Yeah, it supports, and so it supports gestures, switches. So probably the main controls supported.
Yeah, so well, I've seen Flutter's got gamepad support with Flame engine. I don't know if that hooked into any of the built-in stuff.
Actually, I don't know.
I guess it's a question for the Flame guys.
Yeah, not for me.
There's a focused traversal mechanism, so you
Okay.
can,
Tab through.
yeah,
So
you can,
as long as you're taking input from your controller, going to the focus mechanism, then you will invoke all the built-in accessibility.
potentially, it depends on the mechanism and the API with the controller, but I believe there's like a request focused traversal right, for example,
Yep.
one
Yep.
left. So you could, in theory, you could hook that up to a keyboard and make one left, two down, yeah, whatever you want.
Yeah, no, totally.
Yeah, there's something similar. I'm not sure how it relates to semantics, but for focus node, there's
Yeah,
that.
I'm worried now because just looking at the legislation, presumably it would apply to games as well as apps, so you would have to support that.
Don't release it in the EU.
Yeah, no, that's true. Could do. Yeah.
Yeah. The legislations actually have quite a lot of details in there, requirements as well, things you need to test for, like for example, text scaling, animations need to be paused and you need to show a still frame. So there's lots to consider. Graphs, for example, you have to show a table. So there's quite a lot to consider for this kind of stuff, especially for the business we're in.
Yeah, unfortunately, I was not able to cover everything. It's a huge topic. It's only like a tip of the iceberg.
Yeah. Anybody else? All right. Okay. Thank you, everybody. Dennis, thank you.
Thanks.